Distillation, salt, and TDS. What salt can teach you about clean water? Total dissolved solids, or TDS, is a deceptively simple water quality metric that reveals a lot about what's hiding in your glass. To explore this, I conducted a small scale experiment using basic tools: table salt, a filter, and a distillation setup with a TDS meter. TDS quantifies all dissolved substances in water that pass through a 2-micron filter, primarily inorganic salts like sodium, calcium, and chloride, but also trace organics. It's typically reported in parts per million, ppm, which is equivalent to milligrams per liter. High TDS can affect taste, corrosion rates, and biological compatibility. I began with unfiltered tap water, which measured at 432 ppm. After filtration through a standard carbon filter, it decreased by nearly 50% to 222 ppm. After the first round of distillation, it decreased to 186 ppm. To test the system sensitivity, I introduced approximately 1/10 grams of NaCl, sodium chloride, and repeated the distillation. The addition of salt raised TDS to 303 ppm. Distillation again reduced it down to 176 ppm. I continued this cycle, each time adding more salt and tracking how effectively distillation removed it. In one of the final rounds, TDS peaked at over 800 ppm and dropped to 416 ppm after distillation. The trend? Distillation consistently reduced but never completely eliminated dissolved solids. TDS is more than a number, it's a threshold. Infants can consume under 200 ppm, sensitive plants can tolerate under 500 ppm, and high-tech appliances can do under 10 ppm. That's often required. In daily life, high TDS can mean mineral buildup in kettles, off flavors in water, or reduced lifespan of industrial equipment. It's essential in agriculture, aquaculture, and even pharmaceuticals. This wasn't just a kitchen experiment. It was a practical model of how ion separation and vapor phase purification work. It showed the limits of simple distillation and underscored the role of pretreatment for more complete purification. My next step? Expanding this to more complex water sources: brackish water, rainwater, and natural surface water, and evaluating performance of alternate purification technologies, such as reverse osmosis, ultraviolet disinfection, and carbon and ion exchanges. TDS gives us a quantifiable handle on water purity, and with just a meter, a heat source, and a little curiosity, anyone can start analyzing what's in their own supply. Don't forget, clarity does not equal purity. Chemical testing reveals what the eye cannot. Thanks for watching. If you enjoyed this video and want to learn more, like and subscribe. Stay tuned for our next lesson. See you there.